All right, and the last thing we got to learn is about arithmetic sequences. And a sequence is just an ordered list of numbers. Like every time you write down that list out there, that's a sequence. Like I know what's coming next. Okay. Each number in that sequence is called a term. So this would be the first term, second term, etc. Mathematically, we like to call them like the values a sub n. So like the first term, we'd call it a sub 1, a sub 2. But you just say third term, fourth term, fifth term, okay? Because it's what position it's in. And what we're going to learn about in Algebra 1 is some kind of arithmetic sequence. And an arithmetic sequence is a sequence where we always add the exact same thing every time. And the thing that we add is called a common difference. So, say on this one, to get from -7 to -14, you have to subtract 7. Subtract 7. Subtract 7. That's called your common difference. Like here, the first term is -7, and my common difference is -7. Because I just said it was what we add every time. Well, I said subtract 7. I never said add. But subtracting 7 is the same thing as adding a -7. So if you subtract 7, add a -7. Subtract 7 more, subtract 7 more. Okay, to get from -12 to 0, you have to add 12, add 12, add 12. So that common difference is 12. So the next two, 36, 48, 60. Okay, from here to here, you're adding 4/10, adding 4/10. Oops, put the decimal in the wrong place. Adding, did it again, 4/10. So 1.4 plus 0.4 is 1.8, plus 0.4 is 2.2, plus 0.4 is 2.6. All right, sometimes they'll just describe it. Common difference is 4. I'm sorry, first term's 4. Common difference -2. So down 2's 2, down 2's 0, down 2's -2. Okay? These we're deciding whether or not these sequences are arithmetic, which means there's a common difference. Plus 2, plus 2, plus 2. Yes. This is an arithmetic sequence where the first term's 2 and the common difference is +2. Add 2, add 2, add 2. So this is an arithmetic sequence where the first term's -3, common difference +2. Okay, this one, I add 2, then I add 4, not an arithmetic sequence. Now, it may still be a sequence. Like you may spot a pattern and know what's next. Like, oh, it looks like I'm doubling it every time. I think the next term's 32. Very well may be, but it's not an arithmetic sequence. Okay, this one we're adding a half. Adding a half. So if we add another half, we'd get to 2. This is an arithmetic sequence where the first term's a half, and we always add a half. Okay. All right, so this one, oops, that's supposed to say a sub 1. Darn it. Okay, so first term of this, 1, I'm adding 1 every time, and they want the 8th term. So 1, 2, 3, 4, 5, 6, 7, 8. 8, 9, 10, 11. 11 would be the 8th term. Now, there's a quicker way of doing this. So, which is, well, should I tell you now or should I? We'll just figure it out in a second. Add 8, add 8, add 8. So the first term is an 8. I'm always adding 8. Here's the first 4, 5, 6, 7, 8. So add 8, 40, 48, 56, what was that, 64 will be the 8th term. All right, this one, first term's 1. I'm always adding -1 because it's going down 1. So 4, 5, 6, 7, 8. Down 1 more, down 1 more, down 1 more, down 1 more, -6. Okay, but what if I said, what's the 342nd one? Are you really going to want to make that list? Okay, so let's just make up some sequence. Like, I don't know, let's use that one where it's an 8 and a 16, a 24, and a 32, etc. So 8 was just 8. Common difference on here's 8, though. 16 is because you took your 8 and you added another 8 to it. All right. This one, you took the one you... Actually, let's do one where I'm going to change my mind. Let's do like 4, 6, 8, 10, 12. Okay, so my first term's 4. Common difference is 2. I want one where the common difference and the first term are different numbers. So 4 is 4. 6 is 4 plus 2. 8 is the last one plus 2 more. 10 is the last one plus 2 more. So see what you're doing here? You're doing 4 plus 1 of the 2's. Here you're doing 4 plus 2 of the 2's. Here you're doing 4 plus 3 of the 2's. So 12 will be 4 plus 4 of the 2's. And think what it is. This is the first term, second term, third term, fourth term, fifth term. So the sixth term will be 4 plus 5 of the 2's, which will be 14. So see how it's always the first term plus 1 less than what term you're on? Number of that differences. So there's a formula. The nth term is the first term plus 1 less than where you are, number of differences. And that's awful handy. So like if I said, what's the 342nd term of all the ones above? Okay, so we could just come up here and say, well, it's the first term plus 341 of the common differences. So if I wanted it on the first one, I'd go 4 plus 341 times, why did I put a sub 1 is 1? I'm at 4. 1. And that would give it to me. This one, it'd be 1 plus 341 of those negative ones. Here, it'd be 8 plus 341 of those differences. Okay? And that's just showing you what that term is. So, and I left some space to talk about it, but we kind of already did. So find the 88th term. So the 88th term will be the first one plus 87 differences. So my first term's 7, my difference is 3. So 87 times 3. Can't believe I'm punching that in the calculator. Apparently it's too early in the morning for me to think. There's 200. I actually punched that in a calculator too. I'm a little ashamed. It's 268. So find the 105th term of this. Okay, first term is -9, and I'm always going down 1. So the 105th term is the first term plus 104 of those differences. So I'm going to end up with -113. Okay, and sometimes we'll get little word problems. So total number of babies born in a country each minute after midnight on January 1st can be estimated by the sequence shown below. So it's not saying like in the first minute there's 5 born and in the second minute there's 10. It means after the second minute's up, there's been 10 total babies born. So find the common difference of the sequence representing the total number of babies. Up 5, up 5, up 5. Find and interpret the 7th term. If I was just going to the 7th, I might as well just make the list. Maybe 30. Okay. So minutes after midnight on January 1st. So 7 minutes after midnight. So by 12:07 a.m., there have been 35 babies born in this country. Okay. Estimate how many babies will have been born in this country by 1:35 a.m. Okay, so it's midnight. Let's get to 1 a.m. That's 60 minutes worth right there. And then to get to 1:35 a.m., we got another 35 minutes. So that's a total of 95 minutes worth. So what I want is what's the 95th term of that sequence. So it's going to be the first term plus 94 differences. 5 plus 94 fives. 94 times 5. 470. So there will have been 475 babies born in that country by then. And then when they say how many minutes, well, we want to know how many times I've added that. I'm hunting for how many, well, not what the difference is. I'm hunting for how many terms I'm on. So if this is my formula that will take care of any arithmetic sequence, I want there to be 100 babies total been born. So I want that number right there in the list to be 100. I know the first term was 5. I don't know how many terms there are, but I know that it always went up by 5. So over here, 5 minus 5. So how many minutes after midnight did it take? Be 20 minutes worth. And you could have actually made the list out and still gotten it right.